Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video on these topical multiple choice questions, I'll go through the nitrogen and sulfur chemistry. So this is section 9.4 in my classification. It's got nothing to do with whatever is in your textbook really, it's just my classification. So as I go through these multiple choice questions, I hope it helps you to recap very broadly what kind of concepts you would need to be you are expected to master at AS level chemistry, whatever chemistry curriculum board that you're doing. These are the fundamental skills and knowledge that you require, that is required of you to master more complicated concepts from here onwards. So it's talking about sulfur dioxide now. So sulfur dioxide is an important food preservative. So it is a gas, but does it make it useful in this role? So you always gotta play into the context of what is being asked of you. So it is a gas, is a correct statement. It is a reducing agent. Is it a reducing agent? Well, we call SO2 as antioxidant. Antioxidant because it prevents, it doesn't like, okay, so it prevents oxidation. Okay, it prevents oxidation, antioxidant. So it prevents your food from getting oxidized, all right? So it does not react with oxygen to form sulfur trioxide. Remember, you need the equilibrium. You need the equilibrium in industry. So it doesn't happen just on its own, Apart from in the upper atmosphere, when we talk about atmospheric chemistry, you have something else that is the catalyst. So it's not going to be C. It reacts with water to form you an acidic solution. It does. I mean, there's sulfur plus 4. In the general periodicity, you would have known that will give you H2SO3. Where there is the SO3 2 minus ion is sulfur plus 4. When you combine it with H plus, that is how you get H2SO3. So it does react with water to form an acidic solution, but that is not why you use it for food preservative. It all comes down to antioxidant. It prevents your food from being oxidized because it's quite a good reducing agent. Okay? So moving on to the next question. So this one is asking why is ethanoic acid a stronger acid in liquid ammonia than in aqueous solution? So in aqueous solution, you will have water. In liquid ammonia, you just have NH3 liquid, alright? So when you have ethanoic acid, I hope you can appreciate that you can form hydrogen bond like that. So you can form hydrogen bond not just with water. It's supposed in water you will have water like this. So from the lone pair with the electronegative element, so that's how you can label H bond. Gotta have the dipoles, gotta have the lone pair, gotta have the dipoles as well, and the label of course. And then of course if I want to show it dissolving in ammonia, which it will, for the same reason, you have nitrogen, you have the lone pair on the nitrogen, which is electronegative. So that is also a hydrogen bond. But it's asking you, why is it a stronger acid in liquid ammonia? Okay, so we got to think about what is happening here. When you have this, you have CH3CO2H. Ammonia can act as a base as well. So what happens is you can get CH3, CO2 minus, plus NH4 plus. Okay, so the base picks up the proton from the acid. The acid acts as a proton donor. It's a Bronsted-Lowry acid. Give away the proton to the nitrogen there. And then you will form the ammonium, which has the dative covalent bond. If you are just in water, you can partially dissociate as well to give you the conjugate base. So don't say you never heard of this term called the conjugate base. Your specifications specifically said you should know the idea of Bronsted-Lowry acid and bases, as well as the conjugate acid and conjugate bases. So you need to know how to define them, So ammonia is a stronger base than water. That is actually correct, because when it is a stronger base, it takes away the H plus more readily compared to water. Because it takes away the H plus more readily, it readily accepts the H plus. It drives this equilibrium towards this side, and therefore, since you make the acid becoming like this, you make the acid dissociate more into H plus, and therefore, it is what makes ethanoic acid a stronger acid, okay? So moving on to the next question. So this one is asking why is ethanoic acid a stronger acid in liquid ammonia than in aqueous solution? So in aqueous solution, you will have water. In liquid ammonia, you just have NH3 liquid. So you can get CH3CO2H. You can form hydrogen bond like that. So the base picks up the proton from the acid. The acid acts as a proton donor. It's a Bronsted-Lowry acid. Give away the proton to the nitrogen there. And then you will form the ammonium, which it will, for the same reason, So moving on to the next question. So this one is a classic one. It's your test for ammonium ion from your paper 3 practical, not just A level but O level as well. I hope you've seen this ionic equation. They always like to ask this whether you are in a practical component or whether you are in a theory paper, not just in AS but in A2 as well. Whenever you add any hydroxide, whether it's sodium hydroxide or calcium hydroxide, whatever hydroxide, with ammonium, you can liberate, you can release ammonia gas, okay, because the NH4 plus give away the H plus. Now you have NH3. The NH4 plus loses the H plus, is a proton donor. This is acting as an acid. This will accept the proton and it will form H2O liquid. This is the ionic equation for any reaction involving ammonium plus hydroxide, which you need a bit of heat in order to drive the reaction, in order to make the reaction go, perhaps as a source to overcome the activation energy of the reaction as well. Yeah, so lime water is basically calcium hydroxide, and that is your source of hydroxide that will make this reaction happen. Okay, so that one is an oxidizing agent, whereas in this kind of reaction we are doing acid base reaction, so we are not doing oxidation or reduction. This one is acting as an acid. It donates the H plus to this, okay, and the species that you form after you donate the H plus is called conjugate base. This one is the base because it accepts the H plus. The species that you form after the base accept the proton, it is called conjugate acid. These are basic definitions which they like to ask you in, I don't know, in AS as well as A2, yeah? Next up, they're saying that you form this pollutant in the internal combustion engine. So that's where your combustion works to give you the energy for your vehicles, your motor vehicles to work, yeah? What can cause acid rain if you do not remove it? Okay, it's got to be that. This is under atmospheric chemistry, which you need to know that the NO can be oxidized in air to give you NO2, and then the NO2 can oxidize the SO2 to SO3, and then you will get NO, which the NO get regenerated. So you can see the NO acting as a catalyst. So these are the series of balance equation that always asked in theory paper, not just in AS but also in A2 as well. And now that you get a SO3, you can form your H2SO4, which is your acid rain, and the water is basically your rainwater. Instead of doing it in industry, you do not need V2O5 because these are your catalyst. NO is your catalyst. It is regenerated at the end of the reaction. Okay, so you gotta remove NO, and you remove it in the catalytic converter. Well, you remove it by passing it through the catalytic converter before it gets out. So you have rhodium or palladium or platinum. Those are the precious metal, and then you can get less harmful gases. Okay, so toxic stuff goes in, less harmful stuff comes out. This is still a greenhouse gas, so it can still cause global warming, etc., which you can elaborate, of course, yeah? So now they say when you have a solution of ammonia in water, what is present? When you have ammonia in water, you should be able to write this equation. Show that with a partial dissociation of NH3 in water, it will form NH4 plus, the plus is on the nitrogen, and then you will get hydroxide ion, alright? So it dissociates partially in water to give you OH minus ions. What do you have? You would have NH3. Between the NH3 and NH3, you should be able to draw like dipoles, delta minus, delta plus, and then another NH3. There's delta plus, delta minus. So that is your H bond. But do not forget that you can also have H bond with the water, because you are NH3 dissolved in water. So I'm just showing you as an example here. We get hydrogen bond between the NH3 and NH3, but also NH3 and the water molecule, you also get hydrogen bond as well. Okay, so essentially we must have hydrogen bond, okay, but we also have ions. So these are ions because we dissociate the NH3 partially in water to give you the OH minus, yeah? So we do have ions, so see the equation below. Simple molecules, yes, is in equilibrium, so you still have these simple molecules, but you also have ions as well. All right, so this is the end of this 5-question series of questions involving nitrogen and sulfur chemistry. I'll see you in the next video. Please subscribe to the channel if you haven't, and please spread the words and get more people to see if the channel has content that will be useful to them or not. All right, so thank you for sharing. Okay, I'll see you in the next video.